Welcome to Science versus Atheism. If you missed the introduction to the series, I recommend that you listen to Part 0 to get some background on this content. In a nutshell, we're going to examine several ways in which atheism departs from science while pretending otherwise. My father addresses the arguments made in behalf of secular humanism in the Scientific American article entitled 15 Answers to Creationist Nonsense. That won't take place until Part 7 of this series. Parts 1 through 6 will be my father getting us up to speed on precisely what science is equipped to deal with, and what many people have been hoodwinked into believing that it can deal with. Whether theist or atheist, I promise you'll learn something. Even if you're a scientist, you'll likely learn something. Before I begin here, let me express my own understanding that atheists aren't bad people. In fact, I see them as no less valuable than myself. This series is not about bashing people, but rather about purifying the waters of science by purging non-scientific atheist philosophies therefrom. Believe in what you want, but be careful what you call science. Let us begin. A response. Who is this that darkeneth counsel by words without knowledge? Introduction. This is written in response to the article 15 Answers to Creationist Nonsense by John Rennie, Editor-in-Chief, in the July 2002 issue of the Scientific American. The article, being representative of the position of the anti-theist secular humanist movement, characteristically contains misrepresentation to the theist position concerning academics and life and the universe, misrepresentation of true science, and misrepresentation of precise language and logic. The perspective of the response made herein may be likened in analogy to a picture in a newspaper. Looking at the picture with the naked eye, one sees black, white, and various shades of gray. Looking at the picture through a magnifying glass, one sees no gray areas. The entire picture consists of black dots on a white background. The darker the gray, the larger the black dots. So it is with life. Upon sufficiently close scrutiny, there are no gray areas. In the included analysis, we shall scrutinize science and its counterfeits, logic and reason, and some of the associated fallacies. There are legitimate objections to the 15 points attributed by Mr. Rennie. However, the preponderance of mistakes within the article lie with his responses, for which he alone is responsible. While we shall deal with this particular article, most of the objections to theism made by the secular humanist adherents are dealt with. Those not included can be analyzed using the same tools. Due to the nature of the subject, there will be much that is positive and informative concerning theism, and unfortunately, much that will be negative, since it will deal with anti-theism, which is, by its nature, almost totally negative. Upon first reading the following, some will be perplexed by the content, probably because of misconceptions incurred during their education in the presence of non-theism. Seldom do teachers in academia examine issues with the precision that will be included herein. All that are so disturbed are welcome to read, reread, and carefully ponder the content. Doing so will hopefully illuminate and give greater precision of perspective. We start with the pertinent fallacies of reason, move to description as to what constitutes true science and allude to its counterfeits, then deal with some aspects of precise logic. Following a discussion of related concepts, Mr. Rennie's comments on related items and on the 15 objections will be dealt with point by point. And that is it for the introduction. We're going to get right into the fallacies. Fallacies of reasoning usually appear when the claims being made cannot be properly justified. They are counterfeits to solid, substantive reasoning and to the use of precise language. Their standard appeal is to sophistry and emotion. Some are excellent examples of rhetoric, which is the standard basis for most counterfeits to objectivity. All fallacies are external to, independent of, and irrelevant to the logical validity of any claim. Logical validity is independent of who forwards or makes what claim. Pro-fallacies. These are appeals to respect given by segments of society to persons, groups, structures, positions, interpretations, ideas, and the like. Most common is the pro hominem, or for the man, among which is the appeal to authority. For example, he has a PhD, so he must be right. Also included are appeals to institutions, time-honored interpretations, historical and social conventions, and the like. For example, 20 million Frenchmen can't be wrong. Ad fallacies. These are attacks against persons, groups, structures, positions, interpretations, ideas, and the like. The most common is the ad hominem, against the man. These take the form of personal attacks, ridicule, put-downs, and or depreciation of individuals, institutions, and or positions. These may be implicit or explicit. For example, he is a convicted felon, so he must be lying. The fallacy of transfer. This fallacy takes a term that has specific meaning and power in its proper context and misapplies it, usually by definition or false association, to an improper context. This attempts to take properly associated power and meaning and illegitimately transfer this power. It imputes an authority that does not exist in fact. It confuses, misinforms, obfuscates fact, eliminates precision, clouds clarity, and, when done on purpose, lacks honesty. This can be executed by various means. For example, using definition in the attempt to connect by terminology items that in basic substance are not connected. This will be exemplified in the discussion on science. Also, by placing the focal term or account within a list of terms or accounts, having the property or properties, either positive or negative, that one wishes to transfer by implication and association to the focal term or account. For example, a person claims to have had a prescient experience. The detractor will rattle off a list of faked prescient experiences and thus claim to have shown thereby that the first must thus also be a faked experience. I'm going to interject and point out here that other examples of the fallacy of transfer include false equivalence or false parallels. These are fallacies of transfer. Anytime you try to connect two things that are only very loosely connected, and in the final analysis assert that they're basically the same thing, you've got a fallacy of transfer. Continuing on, the post hoc ergo propter hoc fallacies. This, therefore, because of this, also known as circular or begging the question arguments. These essentially say that an argument or claim is valid because it is valid, period, no other justification. For example, survival of the fittest is true because the fittest have survived. This is not the definition of the term fittest, thus is a circular argument. Survival is as likely a matter of circumstance as it is of fitness. A non sequitur, it does not follow. This is an invalid assertion. These assert by implication a relationship between a hypothesis and conclusion that does not exist. That is, an assertion that cannot be justified by deduction within the context of the supporting system. A non sequitur is not just difficult to validate, it is impossible to prove within the given context. For example, if 3 equals 6 divided by 2, then 1 equals 2. Or another example, if the ground is moist, then it is raining. Or another example, if he rides a bicycle, then he must like peanut butter. To explain the fallacy of converse logic, it will be useful to review some of the terminology of formal symbolic logic. So theorem/implication. In words, P implies Q, i.e., if P is a valid statement, then Q is a valid statement. In formal reasoning, the validity of any theorem/implication is established by what is called a proof. This is a sequence of deductive steps starting with the information content of the statements, P, and by application of the information in the background axioms and the underlying rules of inference from the meta-logic producing the statements, Q. Now I'm going to interject and point out that if your head is spinning a bit, bear with me. I know this doesn't come quickly to those who are not familiar with this. If you bear it out and listen, it may come together at some point. Continuing on, converse. The converse of P implies Q is Q implies P. In general context, there is no relationship between the validity of any implication and its converse. They may be both valid, both invalid, or one valid and the other invalid, depending on P and Q. The law of implication from the meta-logic. If P implies Q is a valid implication, and the conditional/hypothesis P is satisfied, then the conclusion Q must also be satisfied. Now the fallacy of converse logic. If Q implies P is a valid implication, and the conditional/hypothesis P is satisfied, then the conclusion Q must also be satisfied. Symbolically, this has the appearance of being the law of implication, but replaces the internal implication by its converse. Interestingly, this particular fallacy permeates the thinking of almost all who are involved in scientific and associated philosophical pursuits, and is exemplified by the statement or claim that checking the conclusion of an implication, i.e. the outcome of an application or experiment, validates as true the hypothesis thereof, i.e. the theory or model that gave rise to setting up and executing the application or experiment. For example, if P is a theoretical model designed to predict outcomes in a real-world application, and Q is the predicted outcome, and we construct a physical circumstance as designated by the hypothesis P, then check to find that Q is in fact produced, then the claim that the hypothesis P is thereby verified is true. That is a fallacy of converse logic. We shall say much more about this problem and fallacy later. But 3 examples. Example 1. If it is raining, then the surface is moist. This is, by experience, a valid statement. That is, if we check that it is raining, we may correctly conclude that the surface will be moist. However, there are many things that can cause the surface to be moist. Thus, if we only check to find that the surface is moist, we cannot justifiably assert that it is raining. The fallacy of converse logic asserts otherwise. Example number 2. An extreme example, but illustrative. If 1 equals 2, then 3 equals 6 divided by 2 is a valid implication, vacuously, which means that whenever the hypothesis statements P are untenable, then any conclusion whatsoever can be inserted, and the implication is vacuously valid. The reader may have to think about this one very carefully. 3 equals 6 divided by 2 is a valid statement. 1 equals 2 is clearly not valid, but the fallacy of converse logic asserts that it is. Example number 3. If P is a prime number greater than 2, then P is an odd number. This is a valid implication, but the converse, if P is an odd number, then P is a prime number greater than 2, is clearly not a valid implication, since there is an unlimited quantity of composite odd numbers. That is, the fallacy of converse logic asserts that every odd number must be a prime number. So I'm going to interject again to point out that basically what the fallacy of converse logic is. In real science, you have to work through a hypothesis to see what the conclusion will be. If all you do is take a conclusion and then try to reverse engineer a hypothesis to fit that conclusion, that is a fallacy. And the reason why that is a huge no-no in science is because there are many different processes by which you can come about the same conclusion. And so to try to assert that any explanation is the explanation cannot be done unless you work through the hypothesis to reach that conclusion. You have to see how it comes about. You cannot simply make assumptions about how a conclusion came to be as it is. To do so is to commit the fallacy of converse logic. And that concludes this section. In the following section, we're going to talk about science. Thank you very much for listening.